첫 번째 세션은 개방형 공간정보 기술과 스마트 도시를 주제로 3개의 발표로 진행이 됩니다. 각 주제 발표는 25분씩 진행되겠습니다. 첫 번째 발표는 도시 계획을 위한 온라인 시나리오 기반 계획 도구라는 내용으로 호주 뉴사우스웨일스 대학교 크리스 퍼티트 교수님께서 발표해 주시겠습니다. 큰 박수로 맞이해 주시기 바랍니다.
안녕하세요.
안녕하세요.
Apologies, my Korean is not very good, so I'll be presenting in English today. So thank you very much to the Korean Housing Land Authority for hosting this event, and FOSS4G, and for the opportunity to speak to you all today, and come all the way from Sydney, Australia, and talk about smart cities. I'm quite humbled to be talking to you all about smart cities because Seoul and Korea are world leaders in ubiquitous cities and driving forward the technologies in smart cities. So, a little bit about our university and our faculty. We actually have a smart cities research cluster, and a colleague of mine, Dr. Hoon Han, who is a visiting professor at the Seoul National University, who's here at the moment, is the convener of our Smart Cities theme. It's run out of the Faculty of Built Environment, for which I am based. And we have a research centre, the City Futures Research Centre, that has been around for 10 years. We have 5 programs of research looking at improving the well-being and quality of life of our cities, and looking at addressing issues of equality and well-being. So I'm the program leader for the City Analytics thematic, where we look at urban analytics, modelling, visualisation and simulation of cities. So we have a number of projects underway in our City Analytics area, and I've been there now for about 12 months, and one of the most exciting projects that we have, I just want to touch upon, is this project we have where we're obtaining information of cyclists as they cycle through Sydney, and we can start to see how they're moving through the city. I'm going to try and go to our website if this works. So we use visualization tools as a front end to a number of our data sets and models. And we have, for example, this bike analytics work, which is based on the Leaflet open source product built on by CutODB. And we can start to then track individual cycled movements through our city using information collected by a smartphone app called Riderlog. And then we can start to look at various indicators around the cyclability of our city, and we know that the number of female cyclists is a lead indicator of the health of a city's cyclability, and we do not have good numbers of female cyclists in Sydney. It's around 10 to 15%. So this information, which is made accessible via a geospatial interface, enables planners, decision makers to really plan for smarter cities. And with the movement of open data, there's a number of dashboards that have been built, and we've recently just built this Sydney City dashboard, which is all based on open government data. So last few years, we've had a big push in Australia for releasing hundreds or thousands of data sets, and these are some of the data sets that we have coming through our dashboard. We have cameras on traffic condition, we have information about weather stations, we have air quality, which I believe is a big issue in Korea. We also have a hole in the ozone, which is very close to Australia, And people are very worried about getting skin cancer, so we have information coming in about how strong the sun is at particular times of the day and how much sunscreen you should wear. And for those who are interested in the stock market, there's real-time information coming from the stock market. So this is all made possible by open data. So it's very pleasing to hear that in Korea there is support for open data and open source software. So the last 4 years there has been funding through the federal government in Australia around 30 million Australian dollars, which is probably close to 25 million US. And I think that's a lot of one. And basically we've been building some open source e-infrastructure through the Australian Urban Research Infrastructure Network. And we've been contributing some of this back to the open source community through OzGeo and other endeavours. So we've actually built a portal where all the researchers and government officials in the country can log on and access over 2,000 data sets for all the cities of Australia. And they can access over 100 spatial statistical tools to interrogate this data. This is the high-level architecture. It links into a number of agencies' databases, all made possible through programmatic access through APIs. It's a federated infrastructure. There's statistical tools, visualization tools, collaboration tools, and for more sensitive data, there are role-based security mechanisms, so all the data is not shared with everyone necessarily. So the flagship product, the subject of my presentation today, but I'm happy to talk to others about this afterwards and actually show you how it works, is the Orin portal. But what we also have, and this is an example screenshot of that, so we can bring in information around Sydney, we can bring that in a number of visualization tools, graphs, scatter plots, maps, and then we can interrogate this information, we can search and download this information and put it in other packages like QGIS or other packages of choice. But what I want to focus on more now is around this area around spatial decision support tools. So through Orin, there's a number of tools that have been developed, including the online What If tool, which I really want to share with you. But I also will talk about some of the other tools that we have. So under the umbrella of decision support systems, we have the emergence of spatial decision support systems, which have really been supported through the GIS community. And really we have a generic suite of these spatial decision support systems. A number of those I'm sure you help create or you use regularly. A subset of spatial decision support systems have been categorized as planning support systems. And these particular tools are focused on addressing the needs of our city, strategic planning, and how we move forward in governing our city and planning for future scenarios and land use allocation and transport plans, etc. So underpinning a lot of these planning support systems is a scenario planning approach where I've been researching for the last 20 years. And how do you create envelopes of various what-if scenarios? Because we know we cannot predict or forecast the future. We do not have a crystal ball that will tell us in 20 years' time this is precisely how our city will look. So we need to explore various scenarios, and there's various benefits in being able to explore such scenarios. So the scenario planning approach is based on the best available data, so it is a bad approach. It utilises the best available data analytics and modelling, and a lot of this modelling is not complex. And if you're working with city planners and communities, you need to have a degree of transparency. And if you start to build very complex models, as we saw in the 1970s, there is a backlash from the community and from city planners and from officials on what does this mean and what determines the outcomes. So very important are the geographical visualization interfaces, whether they be 2D interfaces, whether they be 3-dimensional interfaces, or 4th-dimensional, and we're factoring the dimension of time. So then we can start to explore an envelope of what-if scenarios. So if we look at various scales, we have various spatial decision support system tools. At the precinct scale, another tool that's just recently been launched as open source, and this is the first conference that we're actually going to give the URL out for this. It's on GitHub, is the Envision Scenario Planner. We have another tool called Envision, which operates at the local council level. And we have What If, which can run across whole metropolitan regions. And then we have haptic devices. We might have our desktop GIS, we might have our tablet that we can interact with this information, and we might have devices like map tables. This is one of the map tables that we have been developing on in Australia, and by enabling various stakeholders in the planning process to interact with the information in a group setting, we're finding this is a very, very powerful medium in communicating and exploring and designing collaboratively what the future of our cities might be. There's another screenshot of the map table that can go horizontal, it can go vertical. It has wheels, so we can wheel it into various rooms. So it's quite mobile. So this Envision Scenario Planning tool, which is not the main focus of my presentation today, but as of today, it has just officially been signed off by the University of Melbourne as an open source tool, and I'll leave these slides, but there's a link down there to github.com/forum/ESP, and this is a Cesium-based tool that can actually be used to explore various precinct level developments and look at return on investment, look at water use, look at energy use, and to try and empower councils and communities to help redesign their future. We have a building typology library, so you can bring in 3D buildings, and each of those buildings have various attributes, energy use attributes, water use attributes, and various costs for materials. We have a couple of papers on this too. We also have the Envision Planning Support System, which is a multi-criteria based approach, which is driven by property information provided by the Valuer General and the property authorities in Australia. Again, I won't talk much about this tool, but it's another tool you can find by the Auran website. So the What If tool is based on a tool originally developed by Professor Richard Kosterman from Akron University in Ohio, and it came out in the late 1990s. So it's a GIS-based tool. It was desktop. It was written in proprietary. And we worked with Professor Kosterman the last 4 years to redesign, refactor this tool, and make it available as an open source tool, which is web-based. And there's a link to that What If tool if you want further information on the documentation. And again, the code is on GitHub, and I'll leave you those links. So it's scenario-based. It's policy-oriented, and so you can explore a number of what-if scenarios pretty much on the fly. And as I said before, it doesn't attempt to predict the future, but you can start to look at the dependencies and correlations between various variables. So it has a setup module. You need to do a lot of pre-processing, geo-processing using a package such as QGIS, and then you load the information into the online what-if tool. There's a land suitability component, so you can explore a number of scenarios, what-if scenarios, looking at land suitability. There's land use demand, which is more aspatial. It's driven by population projections and employment projections. And then we have a land use allocation engine, which allocates land out to various horizons, whether it might be 2020, 2030, 2050. So that is roughly the architecture. Apologies, there seems to have been some incompatibility with my slides, with what's been shown. But we've got a Spring MVC infrastructure there with RESTful APIs, CouchDB and Postgres databases. With GeoServer, we have authentication coming through Workbench, and that's the high-level architecture. And these are some of the key components within that architecture. So all using open source components. So a particular case study we first used to develop and refactor this tool and test the tools on the city of Perth, which is in Western Australia, which is a big mining area in Australia. A lot of minerals, a lot of gas, and a lot of population growth in recent times. In Australia, we have over 85% of our population living in 5 capital cities, and Perth being one of those cities. Interestingly though, almost the entire Australian population could fit into Seoul. So with Seoul having a population of over 20 million, it's very interesting to see such a large metropolis such as Seoul and how it functions when we look at that's our entire population pretty much for Australia. But we're fairly confident this tool could work for Seoul also. So we have a population growth, as in most countries, a significant population growth forecast, and so we need to find land for this population. We need to maintain the quality of life for those living in those cities such as Perth. So we have a trade-off between environmental areas of importance and land that might be freed up for future growth. So we worked with the Department of Planning over there in developing these scenarios. So we looked at a scenario around maximising employment around the university. So we initially tested the model just up in the northern area of Perth, and we explored 4 various scenarios. So this is what the screen interface looks like, some of the screenshots for what if. So you go in there and you can then access your various modules for setting up all your information for your demand scenarios, your allocation scenarios, your demographic trends. And so then you upload your information as GeoJSON or shape files. You determine what your metrics are, and you put in some base information before you can run your various scenarios. So I won't go through all of this, subject to the constraints of time, but I'll leave these screenshots in the slides for you. So within the pre-processing, you need to create buffers. You need to create unions of various data sets to determine what are the key factors. Is walkability, for example, in Perth, they suggest walkability is within 1,600 metres of a train station. And so we created buffers of 1,600 metres, 800 metres, 400 metres to a train station. So the land suitability module is very simple mathematics. It's multi-criteria evaluation. And we found keeping it simple for such a tool, which has a lot of complex information, keeping the math simple actually has meant we've got greater buy-in by the planning authorities and those that are studying planning who would like to have a greater degree of certainty of their underlying models. There's interfaces like this where in a group decision-making environment, various officials, planners can then change various weightings of importance. It could be increasing the importance of public water supply, or increasing the importance of railway station commute times, or how close we should be to a university, or do we not allow development to occur in an ecological sensitive area such as a wetland. But again, these are all subject to what the planners think are important, what the decision makers at the time, and they can then actually determine these scenarios for themselves and explore the trade-offs between one scenario and another. And then we come up with maps like this, which align to the cadastre. So we get our heat maps. The dark green areas are more suitable for low density housing in this particular scenario, and the red areas are constrained because they might have ecologically sensitive habitats, like cockatoos, or it might even be kangaroos. And then we have a series of these maps. So this is our map for medium density land, somewhat different to low density. And then we have high density, so we're promoting high density around health sectors and the university. And then industrial land is a lot less land suitable for industrial land under these particular scenarios. And then future land for commercial. So you set up these various land suitability scenarios. So then we look at the demand module, which is driven by population projections coming through the Australian Bureau of Statistics or various state government agencies. And we can see in this area we're expecting an additional 12,000 new dwellings up until 2031. And there is a demand module within the tool that we can start to input these particular metrics. And we can also then specify what our vacancy rate is, What is the breakdown of density between high, medium and low density? We have quite a variety of densities in Australia. We're not as high density as what you are here in Korea. We have a big move towards higher density, medium density, but there's still a number of people living in single detached dwellings. So we can then map various employment projection figures from various industry classifications to various land use types. And then we can give these figures of employment projections. So the land demand module is governed by a couple of equations. This particular equation determines how much additional land is required for residential land. And this particular equation looks at how much additional land do we need to support employment around industry sectors. And again, there's graphic user interfaces for inputting all this information, so the planners can put in those information that they think are most applicable. They might even outsource some employment projection information to a private consultancy and then feed this in at a later date. So then we can explore a range of scenarios from low, medium to high growth. And then the land allocation module feeds in the land suitability work that we had in the first module, and then you can specify growth patterns. So it could be linear growth, it could be radial growth, it could be a combination of this growth. And then you can specify the size of land parcels that are most applicable for growth. We can bring in our utility information, our transport plans, and there's a simple land use allocation method that then allocates the future land until that land has, demand has been met. And again, it has simple graphic user interfaces, and you can save and export your reports as CSVs or PDFs, or download information as shapefile onto JSON. And we get these sort of maps as we start to allocate land. This is some scenarios we developed a couple of years ago, so moving forward a couple of years here, and then future land allocated in 2031. You see that the changing blue is additional land that's been allocated to commercial in this particular scenario. So then we applied, in fact, the tool for all of Perth, and after we did our test in the northern regions of Perth, so we've been able to run this tool now on about 1 million polygons, and when we run these scenarios, it takes a matter of minutes to actually run these scenarios. So we can run these scenarios in a workshop environment. We don't have to go away and recompute our scenarios and bring those back to policy decision makers. Using the map table or other interfaces, we can actually run those scenarios in near real time. So conscious of time, I'm going to go through this very quickly because I'm not sure how much that's going to be now for the last few minutes of my presentation. So we ran 5 scenarios looking at peripheral growth of the city, more compact developments, a high density, the likely city based on the current planning strategy, a transit city where we try transport-oriented development, TODs, which have done very well here in Seoul and in Korea, and then activity-centered city based on jobs and employment. So if we look at the likely city, we can then bring in our existing strategic plan, and we can then look at infill regulations. We can look at areas that are environmentally sensitive. We can sort of get the model, get the scenarios driven by infill around public transport and activity centres. And then we can bring in information that the Department of Planning had on existing projections that they thought were likely to occur. And when we run the model, what we can also find is sometimes the model actually just stops because you've run out of land under those various conditions. So then you can go back and work out, why did I run out of land in 2034? It's maybe because we didn't have high enough density, or the zoning regulations were such that it was too restrictive. So you can run these scenarios in real time and actually test assumptions and metrics to make sure those scenarios are actually plausible. And those areas in red you can see is where we've run out of land. So you can start to work out in what year you might actually run out of land, and have you run out of land for residential or commercial or industrial or all of the above. So So here's our interface to the online what if. And so then you can start to interact through this map layers interface. You can look at the various scenarios and the various years. So in this particular piece of work, we were extrapolating out to 2051. So that gives somewhat of a flavour of our online what if scenario planning tool. So in Australia there is now a move to use these sorts of tools in smart city planning. Our Prime Minister has recently launched earlier this year a smart city plan that we have for the country, and it needs to be guided by data-driven approaches made possible through geospatial information and open data and the expertise that we have in the room here today. So we have scenarios that can also inform environmental assessment, so not just looking at land use planning, but environmental planning. And what we have found using this particular tool, we can bring experts from various domains in to explore collaboratively what those scenarios might be. What if you have a transport planner with an environmental planner and a land use planner and other experts in the room to help really realise these future scenarios. And in a changing climate, I know you've had some very interesting climate and weather patterns here recently. We are also experiencing some disturbances in our weather pattern, and we have bushfires are increasing. So looking at bushfire overlays and how can we bring in city resilience layers into our models, like what if. So we have the code now released as open source, and we're very keen to foster an international community of developers and users. So if anyone would like to use the code, it's freely available. We encourage you to do so. We also encourage you to contribute those extensions that you make to the code back, so we can make the what if tool a more sustainable product. So they're the GitHub links to what if, to the interface, to the workbench, and the help documentation. So I'll leave you with these slides. So since we have released this on GitHub, we've had 112 users from around the world set up their own cloud-based versions of what if within the Aura infrastructure. We don't know how many people have actually downloaded and set up their own versions of the infrastructure. We have 28 active projects across a number of countries: Pakistan, Egypt, the US, South Africa, Colombia, to name just a few. So it's great to see that the online what if tool is actually being embraced by the planning scenario community. A few references I'll leave, and some acknowledgements. We've got the efforts of Professor Richard Klosterman, who's kindly donated his intellectual property, making this open source, funding and support through the Australian Veteran Research Infrastructure Network, and also endorsement support through the Geo for All initiative, which is supported through FOSS4G, and we actually have an Open City Smart thematic, and I would encourage you all to join us. We have a wiki there that's supported by OSGeo, and there's a link there to the right. And so, or if you just Google Open City Smart, please join us as we try and make this journey towards open source, open data to improve smart cities and planning in the future. Thank you.
크리스 퍼티트 교수님께서 발표해 주신 내용 중에 저희 공사가 추진 중인 공간정보 고도화, 시스템 고도화하고 관련된 데이터 포탈이나 이런 참조할 점들도 꽤 있었던 걸로 생각합니다. 다시 한번 크리스 퍼티트 교수님께 큰 박수 부탁드립니다.